In today's lesson, we are going to learn how we can differentiate from first principle y is equal to cosec x. So today specifically we are going to look at differentiating from first principles y is equal to cosec x, and this is how we differentiate it. So from our y is equal to cosec x, so y can also be written as 1 out of sine x. So cosec x can be written as y is equal to 1 out of sine x. So you apply the changes. So y plus change in y is equal to 1 out of sine of x plus delta x, that is change in x. So making delta y the subject, so we have delta y is equal to 1 out of sine x plus delta x minus y. So delta y is equal to sine, so we substitute in, so we shall have x plus delta x minus, we substitute in the y, so we substitute in the y, so minus 1 out of sine x. So we can go ahead and get the LCM. So delta y, by getting the LCM, so when we get the LCM and simplify, LCM is sine of x plus delta x times sine x. That's the LCM. So above simplified, we get sine x minus sine into x plus delta x. So that's small change in x. So therefore, using factor formulae, when we use factor formulae, we realize that we shall have 2 cos of x plus delta x out of 2, close bracket, sine of x minus delta x out of 2. So when the negative does the effect there, so out of our LCM, so we write our LCM, sine of x plus delta x times sine x. Simplifying what is up, when we simplify what is up, our delta y can equal to 2 cos of x plus delta x out of 2, because x plus x we get 2x, divide by 2 we get x, times sine of negative delta x out of 2. So everything over our LCM. So our LCM is sine of x plus delta x, then times sine x. Then we can divide through by delta x. So we divide through by delta x on both sides throughout. So we divide it even this other side. So we tend now, so as delta x tends to 0, the limit as delta x tends to 0 of delta y out of delta x becomes dy by dx, and also the limit as delta x tends to 0, sine of delta x out of 2 becomes negative delta x out of 2. It becomes that small angle. Now, when we get to substitute in, our dy by dx will become, so we substitute in 2 cos of x plus 0, because 0 out of 2 is 0, x plus 0 times the negative delta x out of 2, everything divided by sine of x plus 0 plus 0, then times sine x. Now simplifying, our 1 out of delta x is still there, so you can cancel those that can be cancelled, the 2's can be cancelled, and also the deltas can go, and then we have our dy by dx, becoming negative cos of x out of sine, so sine x times sine x, which basically is sine squared x, but it's better we write it that way. So dy by dx is equal to, because we are going to use it to bring out some meaning, so cos x out of sine x times 1 out of sine x, so which eventually becomes negative cot of x times cosec of x. So therefore the derivative, when you differentiate dy by dx, when you differentiate a cosec, so therefore the derivative dy by dx of when you differentiate a cosec with respect to x, you get negative cot x cosec x. Thank you so much. Don't forget to subscribe and like this video if it has helped you. Don't forget to click that notification button to receive notification when I upload a new video. Thank you so much. God bless you. Meet you in the next.